All right, so for our bell work and the notes for today, it's the same as Friday, last time we met. You should have it at the bottom of the third page. Bottom of the third page, this example. I'll give you 3 minutes to see what you could come up with, and then we'll go over it. And then we've got like 3 slides of lecture, and you'll have most of the hour to work. All right, let me print off another one for you. No, same as last time. Yep. Does anybody else need the guided notes from Friday? 2? Anybody else? 3? 4? Sure. I believe. I do. I believe that. Okay, so again, this is at the bottom of your third page of notes. Can anyone tell me, first off, what is the degree of this function? It is 4. Why is it 4? That's the largest power exponent. Yeah, that's what we're looking for. And that is an even number. Our lead coefficient then would be 3, which is a positive number. So if you look at your notes from Friday, we know that the graph is going to end somewhere like that. Whereas x goes to positive infinity, y will go to positive infinity too. And as x goes to negative infinity, or as it goes to the left forever, y still goes to positive infinity. Kind of like a parabola. Okay, the other thing we would need to sketch a graph of it are its zeros. If I set this function equal to 0, how would I solve this for x? $100 is a number. I believe that. Doesn't really help us get x by itself. Maybe if there's two terms, right? If they have something in common, we could factor out x. How many times can I factor x out of this? 3 times. And then I'd be left with this. And now that it's factored, I can tell you when x is 0 or what values of x make this function 0. This will be 0 when x is 0, which has a multiplicity of 3. This multiplicity. Good. Or it'll be 0 when x is what? 4/3? With multiplicity 1. Okay, both of those are odd multiplicities. So at those zeros, 0 and what 4/3 would be like right there, is the function going to touch and turn, or is it going to cross through? That's the power. This has a power of 3, and then this factor has a power. It's not written, but it's 1, right? And we just assume it's there because who can be bothered to write ones? Not Mr. Lake. All right, so the first one has a power of 3. The second one has a power of 1. Both of those powers are odd numbers. So does it cross through or touch and turn? It crosses through. So the graph is going to look like this. Cross through, something happens, cross through. That is horrible. Let's try that again, where it doesn't look awful. Less awful. Something like that. The more points you use, the more accurate this is. So if I really cared about this accuracy, I might find the value when x is 1. I might find the value when x is a half. I might find it at -1. I might find it at +2, and just plug those different x values into my function. But I know the graph will end up looking something like this. And to be honest, if I really cared about how accurate this graph is, I would probably just go to a graphing resource like desmos.com and then just type it. It's perfect, right? They're basically the same thing. I mean, they got the zeros in the right spot. Actually, that is a little weird that those zeros are in the right spot. Like the scaling on that. And then that goes up forever, right? All right. Questions about this? Kendall, did you have a question? Okay. It's like they're twins, those two graphs. They're so close to each other. All right, the last thing we're going to talk about today is the intermediate value theorem, which is important, especially if you're going to take calculus. This is actually a question on the AP Calc test, is the intermediate value theorem. So if you already know how to do it, you are, you have a head start on everyone taking calculus who doesn't. And it's on every calc test, the intermediate value theorem, at least once. All right, anybody need more time? Okay, let's talk about the intermediate value theorem then. So I already did all this stuff. Last thing we need to do is intermediate value theorem. The intermediate value theorem states that if you have two numbers, A and B, where A is less than B. As you can see, A is to the left of B. And a polynomial function f, where the outputs, f of A and f of B, your y values are different numbers. They're not the same number. Then in the interval between A to B, f will have to take on every y value between f of A and f of B. So I'm just going to make up some numbers maybe to help explain this. Let's say A is 5, this is 10. I don't know, let's say this is 6 and 12. The idea here is it's impossible for me to get from 6 to 12 without passing through 8. There has to be some x value that gives me the answer 8. Similarly, there has to be some x value that gives me the answer 8.5. There has to be some x value that gives me the answer 9. Every y value between 6 and 12 has an x value that produces it. That's the intermediate value thing. All those intermediate values, the ones between 6 to 12, have solutions. Does that make sense? Picking up what I'm putting down. You ready to see it in action? All right, so for example, if you had a function that would be difficult to solve, like this one, 12x cubed minus 32x squared plus 3x plus 5, we can find its solutions, or where its solutions are, by looking at the function and applying the intermediate value theorem. So how you could do this is, I'm going to have to stop share and reshare. Let's stop share, reshare, whole screen. I could take my TI-84 and type in the equation. 12, oh, clear. 12x cubed minus 32x squared plus 3x plus 5. And then if you hit second graph, you can pull up the table, which is awful right now. Hold on, what do I want? Second table set. Tables start at 0, count by ones. Yeah. Okay, so if we look at this, I can tell you that there is going to be a solution between -1 and 0. Does everyone see why? What happens at -1 to 0? It switches from a negative to a positive number. It would be impossible to do that without passing through 0. You see that? You pick up what I put down? There is a solution between -1 and 0. So that's one. One solution is between -1 and 0. Because between -1 and 0, it switches from negative to positive. There's another solution at between 0 and 1. Because it switches from a positive to a negative. It's impossible to get from 5 to -12 without passing through. Yeah, pass it through the x-axis without passing through 0. So there's another one between 0 and 1. And I think it asked for one more. And there is one more. Does everyone see where it's at? 2 to 3. Between 2 to 3, there has to be one more 0. Because you pass from -21 up to 50. And again, it's impossible to get from -21 up to 50 without passing through the x-axis or without passing through 0. So those are 3 values, 3 intervals in which there is a guaranteed solution. Yay? And then if you're a calculator, right, you could guess and check like, is it negative 1.5? And then you can zero in on those ranges until you can find out what the actual one is, right? And then once you know like the actual number to whatever significant figures you want, you could go hand it to your boss at NASA and be like, here's the solution. That's actually what your calculator does, is it will check those. It'll go from -1 to 0, then -1.5. Is it to the left or right of that? Then -1.75, and it'll until it finds the solution. That's what it actually does. Yay? All right, your turn. Graph this or type this into a TI-84 and tell me between what three integers do you have a solution? And then that's it. So once you're done with that, you can start working on the homework. I tell you what, no, okay. I'll start a time. I was drinking this, getting ready to taste coffee, and then I remembered that I already drank all my coffee and filled this up with water. Water tastes really weird when you expect it to taste like coffee. That's true. That's a fun prank you can play on your spouse or significant other. You can hand them root beer, like in a closed container, and say, hey, would you like some orange juice? Really mess them up. Because then when they taste it, they go, whoa, this is root beer, not orange juice. Whoa, I wasn't expecting that. You could be like, pranked you. And then they are pranked. They can't get out of that at that point. They have been pranked. Well, then you prank them. And then you could, you pranked them. Kaden, you're not telling me that you ever had a Skittle and said, hey, would you like some M&Ms to somebody? Have you done that? Yeah, I do that all the time. Why? Do you want a Skittle right now? No. Okay. I've got some Skittles right here. Because then they're pranked. Whoa. Sure. Whoa. Come on. You gotta prank them, Kanan. Yes. These are the best pranks. Taking out soap dispensers in a bathroom. TikTok should be, hey, here's an M&M. Uh-oh, it's really a Skittle. Gotcha. People come to me about what we should do for senior pranks all the time. I have great ideas. Yeah.
I saw a TikTok
Oh, yeah? That is actually a little depressing. Yeah. They're like, hey, you know what I want to do with my weekend? Go to school again. Go back there. No, that could be fun. Do they have a campus style?
Yeah.
Okay, that you have to have a campus style for that. That's true. That's true. I had a debate tournament here one year where someone got murdered after the debate tournament was over.
Here?
Uh-huh.
Murdered here?
Murdered. No. After the debate tournament was over, but it was a drug deal that went bad. It was a long time. Yeah.
They were murdered.
Uh-huh. That was a long time ago. You know I wouldn't say yes if I was. What are you talking about? All right, so let's do this one. Y equals x cubed. Nope, that's not how you do this correctly. All right, you have to type all the numbers. X cubed minus 4x squared plus 1, and then you hit second graph. All right, there are 3 places Oh, there's actually 4, isn't there? Wait. No, there's not. For some reason, I saw there's a negative 26. All right, what are the 3 places? -1 is 0, switches from negative to a positive. And 0 to 1 switches from positive to a negative. And 3 to 4 switches from a negative to a positive. Those are the 3 intervals where there's definitely a solution. And if you were really curious to know what those solutions were, you could hit graph and then hit second trace and use option 2 to find the zeros. And literally, it will do exactly what I told you to do. If you move to the 0, go to the left of it. Move to the 0, go to the right of it. Move to the 0 and guess. It will keep bouncing forth, splitting that interval in half, and then half again, until it gets to 1, 2, 3, 4, 5, 6 decimal places of accuracy, and then it stops. That is how your calculator finds those zeros. So the 0 between -1 and 0 is negative 0.47284. Isn't that neat? If you want to be a programmer, this is a technique that you have to learn how to program. All right, questions about that? You have the rest of the hour to work. It is 1:43, so you have what, 25 minutes here? No, even longer than that, right? 35 minutes? 30. Hold on. No, I was right. 25 minutes. 25 minutes. So no one should leave with homework today unless they want to. Or maybe just a little bit. Yeah, I can. Let me show you. All right, I'm going to stop recording now.